Please welcome Marius Rosenberg, RWTH Aachen University.
Hi, my name is Marius Rosenberg. I'm the Managing Director of the Excellent Startup Center at RWTH Aachen University. It's my great pleasure to introduce to you Sebastian Waters from Team InCirT, an RWTH spin-off. The team has developed a technology that will be used on a component in our smartphones and tablets that will increase the efficiency and productivity of these devices not by 10x but by 100x. By increasing the energy consumption and the efficiency of transmitting and receiving data, this technology will enable a completely new use for these smart devices. So welcome with me, Sebastian Waters from InCirT.
Breaking the wall of high-speed wireless communication. Sebastian Waters, InCirT.
Hi everyone. Many of the devices that you see on the slide accompany our everyday lives, and I'm sure at least one of them, and more likely several of them, have been used just today by every person in this room. Cell phone, laptops, tablets, trains, drones, AR/VR systems, autonomous cars, routers and repeaters that make up your home networks, base stations that make up mobile phone networks. They all have one thing in common. In order to connect to a wireless network, they all rely on the same standard component, a transceiver microchip. For this microchip, we have come up with a groundbreaking innovation. Here with me, I have our latest prototype mounted on the PCB board. The actual size of the chip is 2 by 2 millimeters. For the next generation of wireless networks, such as millimeter wave 5G, Wi-Fi 7, 6G, current transceiver technology is not suitable. Transceivers capable of 6G performance do not exist. Transceivers capable of millimeter wave 5G or Wi-Fi 7 performance do exist. However, they have severe shortcomings. They are very high in energy consumption. They're expensive because either they rely on expensive materials or on semiconductor technology, for which there's very scarce manufacturing capacity in the world. And on top of that, they're expensive to integrate into larger systems. Our solution does not suffer from any of these shortcomings. Our microchip is up to 100 times faster than even the most advanced, currently commercially available transceivers in the market. This means it fulfills even the highest performance requirements, such as those of 6G. It is also 10 times more energy efficient, which makes it ideally suitable for mobile applications. And on top of that, it is made up of cheap materials, it is cheap to manufacture, and it is easy to integrate into larger systems. So how do we do it? Microchips in general are made up of small switches called transistors. A single microchip can contain millions and billions of these transistors. Historically, the industry has improved the performance of their chips by decreasing the size of the transistors. If you imagine a microchip being made up of Lego pieces, they have decreased the size of the Lego pieces as depicted on this slide. The problem with this approach is that this becomes more and more difficult, and more importantly, soon it will be physically impossible when a single transistor will contain only a few atoms. Our approach is different. We do not rely on miniaturization. Instead, we change the architecture of the chip. If you will, we rearrange the Lego pieces. We do that in order to apply a very well-known mathematical concept, which allows us to process data in parallel, which previously was processed serially. Our technology is patented in the US, in China, and in Europe. At InCirT, we focus on the development and licensing of semiconductor IP. This means we effectively provide blueprints of our microchip to our customers who are responsible for the manufacturing. Our key market is the market for millimeter wave transceivers in telecommunication. This market is expected to reach a volume of 20 billion euros by the year 2030. The value of the semiconductor IP that we provide makes up 15 to 20% of that, which translates into 4 billion euros. We are currently working on our first marketable product, which we aim to release to the market by the middle of next year. We have already received significant customer interest. Most notably, we are collaborating with Nokia, one of the largest network equipment manufacturers in the world, to develop a first 6G-capable base station. This is our team. Together, we combine for more than 60 years of experience in technology and business development. We are currently looking for strategic support with regards to product strategy and market entry strategy. And if you can provide any of these, please reach out to us and help us enable the future of high-speed wireless communication.
Good. 4 minutes Q&A. You know the rituals now. You know how it works. So let's go and straight to the point, because every second counts, as we could see for the Q&As before. So, who would like to take the first question? Here, Emma, please. Thank you.
So, do I understand correctly that part of your key innovation is a new way to optimize circuit design? Is that no?
Well, the innovation is the circuit design. So
Okay.
first of all, previously I think more or less the same chip architecture has been used, and they have just changed or miniaturized the components of which they were used. And this meant if transistor becomes smaller, it can be switched more quickly, and it consumes less energy, which is desirable. But at some point, it reaches a limit, it becomes more and more costly and more difficult to actually improve that performance further. And the idea was actually born at the chair, when the chair didn't have access to the very advanced semiconductor technology, and they had to think of a way to build a high-performance, DAC, ADC chip, what it is in fact, without having access to them. So they thought, how can we build this without having access to the latest semiconductor technology? And that's when they became creative and came up, okay, well, we can actually use a completely different approach, and it turns out that this approach is vastly superior to what exists today.
Mm-hmm. Next question. Here at the back, and then right after we'll have Sabine. Sorry, they're already there.
So I understood it's going to be faster and better energy-wise, but is there also a change towards more higher reliability? So will it be also suitable for like critical applications, or don't you observe these effects?
It will definitely be suitable for critical applications. So basically any ADC, DAC that is used today in any application can be used by this. It's really a plug-and-play replacement of that.
Mm-hmm. Great. Can we have here Sabine in the first row of the jury?
So thank you. Even if it's early stage, and you mentioned Nokia as a potential customer, who else are interested in? Do you have some other names you can share already?
Well, I mean, eventually anybody who is active in semiconductor technology, so to speak. I guess our dream customer at some point would be Apple, if they imply this chip in all of their microphones. Just as an example, for instance, the latest iPhone, for instance, can connect theoretically to the millimeter 5G networks, but it can't send on that network, because if it was, first of all, the technology to send data via millimeter wave 5G networks, you need a transmitter which is too large to even fit into a cell phone, and if we were to transmit over it, it would drain the battery within minutes. And there's the difference where we can provide the technology. It's on a size you can actually put it in a cell phone, and you can actually use it without the battery going dry very soon.
Okay, thank you. Next with Lamine, please.
Can you say something about competition in this market?
Yeah, of course. I mean, the key players in the market are large corporations. There's someone like Analog Devices, there's Qualcomm, there's Texas Instruments. So these are really the behemoths, so to speak. But through our model as being focusing on the licensing, which is actually quite an established model in the semiconductor industry, we think we can compete with them anyways. And effectively, I mean, I guess the end of the story will be that one of these larger players will be so interested in our technology that they want to make it part of their own.
Okay, last question by the 19 seconds. So yes, no question, fast question.
Okay, you are in the moment at technical readiness level at 6 around, and you're going to have a minimal viable product ready next year already. Is that correct?
Not quite. Next year we will aim to release a product to the market that will be vastly better than what's currently in the market, which is still not our final version, but will then come later down the line.
Okay. Thank you very much. That's it already. We're done. Thank you. And